Hello, happy to see you all online. This is Mr. Lin. Today we will start the second part of Lesson 20, Magnetic Poles and Fields. First, we are going to define magnetic poles. Magnet can act as a compass. If you hang a bar magnet at its center of gravity to keep it in balance, the end that points northward is called North Pole, and the end that points south is called the South Pole. Magnetic poles produce magnetic forces. Magnets attract and repel without touching. The interaction depends on the distance. Based on Coulomb's contribution, the magnetic force is following the inverse square law. Question: since all magnets have north and south poles, if you break the magnet in half, what will happen? The North Pole and South Pole can never be separated from each other. Once you broke the magnet in half, each half will become a complete magnet. Unlike electric charge, you can have positive charge and negative charge. You cannot have North or South Pole alone. Like electric force, magnetic force can be attracting or repelling. The basic rule governing the magnetic force is like poles repel, opposite poles attract. Let's watch a video about how magnetic poles repel and attract each other. The video, magnetic poles can attract or repel at a distance. In order to explain this phenomenon, we will have to introduce the concept of magnetic fields. As we have learned from the previous lessons, surrounding a massive object, there is a gravitational field. Surrounding a charged object, there is an electric field. By the same token, surrounding a magnet, there is a magnetic field. The space around the magnet is filled with a magnetic field. If you put iron filings around the magnet, you can visualize the magnetic field. When we put iron filings in the mineral oil and put a bar magnet inside, this is what will happen. The electric field lines always spread from the positive charge to the negative charge. The magnetic field lines always spread from the North Pole to the South Pole. Near the poles, where the lines are closer or with higher density, the strength of magnetic field is much stronger. Now, let's introduce the units of magnetic field. Tesla, T, or Gauss, G. 1 Tesla is equal to 10,000 Gauss. Question: what will happen if we place a compass in the field of a magnet? A magnet or small compass in the field will line up with the field. In other words, the compass will point from the North Pole toward the South Pole in tangential direction along the magnetic field lines. By the way, what is the source of magnetic fields? Each electric charge is surrounded by an electric field. In addition, the same charge is surrounded by a magnetic field if it is moving. In other words, moving charge creates magnetic field. Our next question is, what types of electron motion exist in magnetic materials? First, electrons are in constant orbital motion about atomic nuclei. This moving charge causes a tiny current and produces a magnetic field. Electrons spinning about their own axis also count as a charge in motion and thus creates another magnetic field. Every spinning electron is a tiny magnet. Electrons spinning in the same direction makes up a stronger magnet. Spinning in opposite direction cancels out. The field due to spinning is larger than the field due to orbital motion. For ferromagnetic elements such as iron, cobalt, nickel, and most of their alloys, the fields do not cancel each other out completely. For example, each iron atom is a tiny magnet.